The Sun. Our Sun, which is relatively small for a star, is heavier than any of 95% of stars in the universe. In our previous video we talked of the biggest stars known to us. You can check it out. Well, there are as well such many types, including dwarfs, 11 times lighter than our host star. However, they're actually not the lightest objects in the universe. In the wide range between gas giants and the smallest stars in the universe, there are some fascinating objects known as brown dwarfs or dwarf stars. To understand their nature, let's have a look at how a star is put to life. According to modern scientific theories, stars and brown dwarfs originate in the same star nursery. When nebulae made up of interstellar gas gradually contract under the influence of gravitational forces, pressure and temperature inside the gas increase. The enormous nebulae disintegrate into a great number of protostellar disks, and each of them has a chance of becoming a fully flammable, privileged star at some point. Its destiny depends on how much matter the young star will manage to capture. If the mass of a protostellar is over 9% of that of the Sun, thermonuclear reactions are bound to start in its interior. Nuclei of light elements like hydrogen, deuterium, helium or lithium blend together, emitting a great amount of heat. This heats up the interior of the future star even more. And more matter is involved in these processes. This unleashes a chain reaction which may persevere for billions and billions of years until the substances fueling it are totally depleted. And so a new star is put to life somewhere light years away from us, and can probably be observed in the sky. Its future depends on its mass and chemical composition. Most of its life cycle will be spent in the main sequence phase. Later, the star is likely to disappear. It is likely to turn into a white dwarf, or alternatively a neutron star or a black hole. But what if the mass of the forming protostella is smaller? Then the gravitational pressure will not be enough for the heat produced by the thermonuclear reaction to increase the star's temperature to the point when it is able to sustain the burning process without additional help from other sources. Nuclear fusion will still take place, but the energy emitted during the process will not be enough for the star to flare up. Instead, the object will slowly decay until the substances necessary for thermonuclear reactions are depleted. It's worth mentioning that every kind of reaction requires a certain temperature to initiate nuclear fusion. If the star's temperature is lower, nuclei will not be able to get closer and will be mutually repelled by Coulomb force. The celestial object we are looking at today is what is known as a brown dwarf in space. Interestingly, in spite of their name, not many of them are actually of a brownish hue. If we could look at them with the naked eye, we would most likely see them crimson, orange or even black. The color depending on the surface temperature. The hottest brown dwarfs have a temperature not higher than 4000 Kelvin, which corresponds to a faint red glow. Most of them are much colder, from 400 to a couple of thousand degrees Kelvin. The peak in their radiation is in the infrared range, which is invisible to the naked eye. Just to compare, the coolest star's surface temperature is about 5000 Kelvin. By radiating heat into its environment, a brown dwarf gradually depletes its energy and cools off. Thermonuclear reactions in its interior die down and the object turns into a ball of compressed gas. It will cool off gradually and will resemble a gas giant of impressive dimensions. After its heat has slowly dissipated, a brown dwarf may in theory cool off to as little as 5 Kelvin, the background temperature of the universe's relic radiation. However, the temperature of the coolest space objects of this variety that have been discovered are about 200 Kelvin. There are several celestial objects that may yet earn the title of a brown dwarf. One of them is WISE 1828 plus 2650. It is in the Lyra constellation and is 47.5 light-years away from the Sun. It is considered the coldest brown dwarf to have been discovered, although astronomers make scientific contributions every day, and perhaps we will soon hear of still cooler objects. A brown dwarf's dimensions are usually comparable to those of Jupiter, while its mass is several dozen times that of Jupiter. For example, the object Corot 3b in the constellation Aquila, about 2,200 light-years from the Earth, is similar to Jupiter in its diameter, but is 22 times heavier. A space object qualifies to be called a brown dwarf if its mass is approximately 12.5 to 80 times that of Jupiter. Objects heavier than that are red dwarfs. Those lighter than that are sub-brown dwarfs, super Jupiters, and planemos. It goes without saying that such small and dim celestial bodies are practically impossible to see with a regular telescope. The existence of these fascinating objects was predicted back in the 1960s, although even special infrared detectors were unable to spot brown dwarfs for a long time. Many years passed before the first brown dwarf had been detected. The great event took place in 1995. The find was an object dubbed Tadari, a rather hot celestial body for its class. It is located in the constellation Taurus, approximately 400 light-years away from the Sun. Its surface temperature reaches 2600 Kelvin, and its mass is 55 times that of Jupiter, or 5.1% that of the Sun. In the years that followed, a great number of other celestial bodies of this class were discovered. About 100 of them were detected within as little a radius as 60 light-years from the Sun. The total number of brown dwarfs in our galaxy is estimated at 80 to 100 billion, which accounts for about a quarter of the overall number of stars in the Milky Way. The brown dwarf, closest to the Earth, is just 9 light-years away from the Sun. Brown dwarfs are rather cool objects by stellar standards. That is why they may contain complex compounds like methane. As for the temperature of the coolest main sequence stars, it is so high that electrons leave their nuclei, and thus the substance turns into scorching plasma. Even the simplest two-atom molecules like hydrogen can't endure this harsh environment. There may be planets orbiting brown dwarfs. The first satellite of this kind was detected in 2004. Remember, subscription is free. See you in the next one.